So the presentation I will give today is related to this so-called airborne measurement, with which you can facilitate the acceptance testing and the verification of broadcasting sites. And this is something relatively new that we are now able to provide on the market. So I will not give you really a product presentation, but rather try to sensibilize you on the importance of doing such kind of measurement and showing you a few examples. So Colibrex, as I said before, is a new subsidiary of the LS Telkom AG that most of you should know. We are small subsidiaries taking care of special issues relating to implementation, testing, maintenance and so on of wireless networks, mainly broadcasting, but everything that we will show today can also be applied to other kind of wireless networks, like mobile networks, for example. And our main activities are dedicated to airborne measurement services. This is our topic from today, and we do also some other things like system integration in special container solutions, for example, and maybe also other things in the futures. Frequency efficiency becomes more and more important. We heard this morning also about digital dividends, and so the consequence is that the spectrum will be more and more full with different kind of services. And also we had a presentation this morning about encoding and multiplexing solutions. Also here we see more and more complex solutions. Also we have the issue of the SFN networks. And why I show these few trends is simply to show that the request for deeper monitoring and the verification overall will, in the transmission chain, will become a key issue. And maybe I show you now this slide, which is a very, very, very simple way how to represent broadcasting network. The investment made to build such a network could be very, very huge. But at the end, the way how the signal will come to the consumers is just these RF radio frequency signals that you have on the air. And this is why we want to point out and to insist on the fact that you have really to verify also what you are on the air. If you are talking about monitoring in such a network, you can have many, many kinds of monitoring of the signals, and sometimes it's very, very expensive equipment. But at the end, don't forget also to monitor really what is going on the air. And now I will show you also what can be the problems you can encounter on the air. So yes, this is the kind of monitoring or verification that can be done, and we will concentrate on the issue of the RF signals. So how to measure an off-air signals? So far, the most common way is to do ground measurements. Once you have installed a network, you will do with a measurement vehicle or with some measurement equipment. At certain points of the network, you will measure your network. This is good, this is giving interesting information, but it's not sufficient, and it has some limitation. And one of the main limitations is that you always get reflection from the ground when we are talking about RF. And that could be an issue, that the value that you are measuring might not be completely correct. And the other limitation is that you can do that only at certain selected points. So you can do some iteration at the end, but you will not, this is not really adapted to verify and to really be sure about especially the antenna patterns and the distribution of your signals over the networks. This is now an example of an antenna where the offset, according to the mast, is wrong, has been wrong mounted. So the question will be, yes, okay, interesting. Why do you show that? Why do I show that? This is a typical, this horizontal diagram, how to show the characteristic of the transmission. This is what the antenna is supposed to give. Just because of this wrong offset that we have just shown on the picture before, the signal which is really distributed is the one on the right side. So we see immediately out of the picture, without being an expert in that kind of diagram, that yeah, there is a difference. Within LS Telcom, as we are an expert in network planning, we did the exercise to do a kind of simulation. And this is what I would like to show you here. This is really a simulation, it's not a real case. The problem that you have seen before on the antenna was a real case. We just took this data now and these two diagrams and simulate what would be the consequence in terms of coverage if we would install this antenna in Berlin. We took it, yes, with dvb-t. And you see here, the red points are all the points that would not be covered, just because of this fault in the installation. Yeah? And you see the consequence would be that you would lose nearly 85,000 inhabitants and nearly 1,000 square meter of coverage. Now let's go for another example. Also was given by Catherine. We just heard before by antenna, sometime a little bit more complex with a half antenna, for example. And here the problem was that the feeder length was not adjusted correctly. Yeah? So the antenna was mounted with the wrong feeder length. And here you will see that you might think, oh, that might be maybe not so clear for everybody. It's a difference in that case in the vertical diagram. So in the vertical distribution of the signals. And here the consequence, we did the same exercise, is here, and you see many red points. Yeah. That means in this simulation that would mean that you lose the coverage of 900,000 inhabitants, nearly 1 million. Yeah. So very huge problem. And just to finish these small exercises, here we just do another simulation, just with the assumption that over the time, this might happen also sometime. Over the time, we have a loss of 2 dB gain, and in this case, okay, the consequences are not so dramatic. But still, you have some red points, and you would lose about 80,000 inhabitants. So, what's the consequence of this example? Let me say. We would say is that the antenna radiation characteristics, they should be verified. And we heard before in the presentation from Marco that they have also a test site. Also Catherine and Romka, they have a test bench in order to measure the antenna. But the thing is, an antenna measured on the production facility doesn't mean could have different characteristics as when it is mounted on the real sites, because on the real sites you get some influences from other factors. For example, from the mast, or for example, from reflection from another tower. Or, as we show with the example, you can get some problems due to wrong installation. So these antenna must be verified, especially when we are talking about very important broadcasting sites. The point is how to do this kind of measurement. So far in the past, the only way to do it was with using conventional helicopter and flying around the antennas. This is still done in some countries, but of course we have an issue. This is first a very expensive solution, and it's not everywhere possible. And also this kind of measurement have some limitation in their accuracy, because the helicopter can not always fly so accurate, yeah, to get the best measurement. So we had the idea within the LS Telcom group, and now with the introduction of the Colibrex company, to use remotely piloted aircraft, or let it call, we can call it drones or UAVs. Yeah? So we don't like to use the name UAVs so much because it has a little bit of military touch that not everybody likes. Yeah? But this development of drones or UAVs, you know, it is really amazing. A lot of applications nowadays are done with this kind of equipment, especially in the film industry, to do some inspection and so on. And because we are an expert in radio frequency and spectrum management, we got the idea to do this development. Means to use such a remotely piloted aircraft. So you see on the picture a small example. So to imagine the size is is a little bit like this, a little bit bigger. So we use this kind of multicopter, and we have adapted a special radio frequency sensors, special measurement equipment to conduct such kind of measurement. I had yesterday evening already a few discussions with some of you that the idea, the concept might be very simple to use such kind of drones, which nowadays you can buy such kind of drones for a few €100 or €1,000. And the problem is we need something very, very robust. We have one issue is that we have to fly in a very strong Earth environment, and we have to provide very secured and very accurate measurements. So what we did is, as you see here, we developed this dedicated measurement sensor. We have a real-time download of the measurement. A big issue is the flight positioning and the flight orientation, because in order to make the measurement very, very accurate, you must ensure that your antenna, your receiving antenna, is exactly positioned where you wanted to have it, at a certain distance, for example, of the antenna, but also with a certain angle, with a certain orientation to the antennas.